Hi and welcome to Calculus 30 with Miss Verity. Today we're going to be looking at section 7.0, which is a review of exponents and logarithms. So starting, we're going to solve for x. Probably one of the easiest ways to solve for x when you've got a non-logarithm term equal to a logarithm term is to change your form. So 5x equals 25. I'm already going to change this to be to the power of 1/3. When you have your x in the exponent, you want to change your bases to be the same. So 5x equals 5 squared, which would be times 1/3, so 5 2/3. Once you've got your bases equal, it's just your exponents are equal to each other. For the next one, change forms. We're going to fourth root both sides. We get x is equal to 2. Normally when we fourth root, we would get plus or minus 2, but we can't have a negative base for a logarithm. For C, again, change forms. So 1/4 is equal to x. For D, you guessed it, change forms. And hopefully we all remember now that anything to the power of 0 is 1. So 5x is equal to 5 to the power of 0. So x is equal to 0. For E, we are going to need to change our look first. We're going to want to get it as one piece, so a logarithm equal to something. I'm just going to quickly scroll down. Here are our logarithm laws. So when we are multiplying, we're really adding. When we're dividing, we're subtracting. When we have an exponent, it goes out front. So we are subtracting, that means we are dividing. So log base 5, 50 divided by 2 is 25. So we've got a log equal to something. We can change forms. And again, when you have your variable in the exponent, you want to get your bases to be the same. And once your bases are the same, you can just take your exponents. On the other side, we've got, we're adding, so we'd really be multiplying. When there's nothing written for our base, it is really a 10. So we have 10 to the x is equal to 1,000. So 10x is equal to 10 cubed. And we can take our exponents. X is equal to 3. Another way you could solve this would be, once we're at this step, we can change the look of this. So we can take our log base 10. We want something that matches this base 10. So 1,000 is really 10 cubed. And at this point, you can just take your exponent, because what would really happen is we'd get 3 log 10. 10 is equal to x. This is really equal to 1, so 3 is equal to x. Expanding fully, so when we are multiplying, we are really adding. Log base 3x plus log base 3y. When we've got an exponent, it goes out front, 3 log x. For this one, we are dividing, so log square root x minus, I forgot the b, log by. Remember that a radical is really to the power of 1/2. So if we move that power out front, 1/2 log bx minus log by, that would be our final answer. For D, we are dividing, so again, we're going to subtract. We're going to subtract everything in this bottom term, so log base 4m. These are being multiplied, so we have plus log base 4n. And simplifying, we're going to put our exponent out front, distribute our negative to everything, so 2 log base 4x minus log base 4m minus log base 4n. This section, it's the same thing, we're just the opposite, we're putting it together. I'll do one example. Log 2, so we're adding, we'd really be multiplying. 5 times 9, simplify, log base 2, 45. Beautiful. So now we're going to solve. I'm not going to solve all of these, but I will solve some of them. So when your x's are in the exponent, you can change forms. You could also take the log of both sides. That would also be another option. But I'm just going to take log base 3, 10.5 equals x. If we were doing exact values, that would be our final answer. In our calculator, though, I'm going to take log of 10.5 divided by the log of 3. Oops, that was not the right number. Log 10. So that is 2.14 is equal to x. For b, we want to get, when solving logs, we usually want to get one log equal to another log. So we're going to combine these using our logarithm rules. So log of x over 3, we're dividing because we were subtracting, equals log of 12. Once we've got one log equal to another one, we can drop the logs. We're left with x over 3 is equal to 12. Multiply both sides by 3, x is equal to 36. Let's do D. So changing the look on this one, we have a 2 out front, which can become an exponent, and we are multiplying. So log 2x squared is equal to 1. I'm going to change the form. So we've got a base 10 here. So 10 to the power of 1 is equal to 2x squared. Divide both sides by 2. 5 is equal to x squared. We square root both sides. We get plus or minus root of 5 is equal to x. But we can't have a negative for our logarithm. So it would just be positive root of 5. I'm going to do one last one. I'm going to do G. So 2x equals 3x to the negative 1. To start off with, we're going to take the log of both sides. So log of 2x equals log of 3x minus 1. Using our exponent laws, we're going to move both of our exponents to the front. So x log 2 equals x minus 1 log of 3. We want to get our x's by themselves, or our x's together. In order to do that, we are going to need to distribute. So x log 2 equals x log 3 minus log of 3. We're going to subtract x log 3 from both sides. So x log 2 minus x log 3 equals log of 3. We're going to factor out x, which leaves us with log of 2 minus log of 3 equals log of 3. And divide both sides by log of 2 minus log of 3. So x equals log of 3 over log of 2 minus log of 3. If we're doing exact values, that's our final answer. You could also type that into your calculator, but